Happy new day to you. Welcome back. So in this lesson, we're going to go through use of the first derivative to find the maximum minimum value of the function. And I have two questions set up for you here and two examples. And both of them, we're going to go through this question right here where we want to find the local max minimum and absolute maximum minimum values of the following functions over a given interval. So let's start up with the first one. We got the first function f of x equal to x over x squared plus 1 is a rational function over the interval -5 to 5, and it could be equal to, but doesn't really matter. So we need to go through the first derivative test and do that. The reason, because we need to find the critical points. To do that, we need to take the first derivative of the function. So let's go ahead and do that. And this is f prime of x equals to, and you're going to use the quotient rule for the derivative, and make sure that you know how to do that. And that's basically the first derivative, which is derivative of top, which is 1 times the function in the denominator, and then minus the numerator times the derivative of the bottom, and all over the denominator is squared. Excellent. Okay, let's go ahead and simplify. When you simplify it, you get 1 minus x squared over x squared minus 1 all squared. So the critical points, you have to set f prime of x, set that equal to 0. That means the numerator, you set it equal to 0. And that means x equals to plus or minus 1. Okay, these are, you got yourself now the two critical points, CPs, right? Critical points. Now let's go ahead and let's analyze what is happening. So now we need to find out when f prime of x is greater than 0. That means, look at the numerator, 1 minus x squared will be greater than 0. That means x, you have to solve this quadratic inequality, and when you do that, you will end up getting, first answer will be x is between -1 and 1, and when that happens, you have f prime of x, which is the first derivative, greater than 0. The next interval is when f prime of x, we want to know when is less than 0. And we're going to do the same thing, 1 minus x squared less than 0. And in this case now, we have that interval, okay, for each one. And let's find out what is the value of the function. So what is f of 1 and f of -1? What is the value of the function at those critical points? So f of -1, when you plug numbers back into the original function, plus 2, so that would be 1/2 and -1/2 for f of -1. Now remember that when we do the first derivative test for critical points, the first value, which is the derivative of function greater than 0, we're just checking if for what values of x the function is increasing, okay? And then for the f prime of x being less than 0 is when the function is decreasing. So in this case, we have found out that f of 1 equal to 1, and in this case, because of it follows within the first interval, that means the function is increasing. So there is a maximum, there's a local max, and with the negative, it follows the first derivative being less than 0, and it's part of the second interval, and that would be local minimum for this function. We haven't found absolute minimum max yet, but that's what that is. And then we are going to use that interval -5 and 5, and let's see what happens with that. Let's do that. So now that we got the interval set up, now I changed it to include the end intervals -5 and 5, just to make it a little bit better so that we can see if there are any absolute max and absolute minimum for this interval. So I'm going to include the equal sign. Even the original question didn't have the equal sign. Maybe I should have put it in there, so just that makes it easier. Here it is. So now when you plug in f of -5, you notice that you get -5/26. And then you do the same thing with the function, test the function at 5, the other end part of the interval, and you'll end up getting 5/26. And that means you have a couple of interesting situations. Now look at these values of the 1/2, 1 and -1, where we have the critical points, and look at the end interval -5 and 5, where 1 and -1 falls between the two intervals. And notice that these values, the value of the function, f of 1 equal to 1/2 and f of -1 equal to -half, these two, 1/2 is larger than 5/26, and f of -1, which is -half, is smaller than -5/26. So when you compare that to versus f of -1, and then the bottom f of 5, you compare that to f of 1, you notice that these values, you got -1/2 and +1/2. This is going to be absolute minimum and absolute maximum. Okay, so they change now from local to absolute within that interval, by the way, within that interval. So the last part of this question is that we need to graph this, just to sketch the graph based on the information that we have. We know that we have these coordinates 1.5 and -1 and -1/2. Those are the absolute minimum max. So let's plot those points. One is in here, one is in there. So this one is 1/1/2, and this one is -1, -1/2. And then based on the information that we have, the value -5 and 5, the graph comes down closer to the x-axis on both sides. So you need to go ahead and sketch the graph, and it will end up being something like this, okay? And becomes asymptotic on both sides. And we can actually find out the equation of the horizontal asymptote using the limit at x approaches infinity for this function. And you notice that it becomes, because the numerator degree is less than the denominator degree, the horizontal asymptote will always be y equal to 0. All right, so now move on to the next question. All right, so this is the second question. Is a trigonometric function? Okay, it's a little bit more involved because you have to remember a few things. First of all, you need to know your sine and cosine functions and their critical points. That means that their x-intercepts possibly, and then how the graph behaves. And on top of that, you need to understand that how to find the zeros of the trigonometric functions using cast and reference angle. So it's quite involved, but same idea applies. We're going to go through the first derivative, we're going to find the critical points and then set it up. So the first thing we got to do is find the derivative of the function. So f prime of x equals, derivative of x is 1, the derivative of sine x is cos x, so that would be minus 2 cos x, and that is the derivative of the function. And then to find the critical point, we need to set f prime of x, the derivative, set it equal to 0. That means 1 minus 2 cos x, you set that equal to 0. And then you need to find what values of cos x. You do the math in here that you get 1/2. You need to solve this cosine equation for 1/2 and get all the angles within this interval, 0 to 2 pi. Okay, so let's do cast analysis here right away. So we have CAST, that's a review of a trigonometric functions and trig equations. So cosine is positive in quadrant 4 and quadrant 1. So the first angle, x, will end up being pi/3. The next angle, you're going to use the reference angle of pi/3, but in a fourth quadrant, pi/3 right here. And then you're going to use the same reference angle here as pi/3, but the new angle is, which is x2, which is 5 pi over 3, and that's just 2 pi minus pi over 3. That's the second angle. So those are the two values that you're going to get. That's x2, and then you got the x1. Those are the critical points. Now let's go ahead and figure out what happens to the function as the first derivative is positive and negative, and then check out the behavior. So the first thing is when f prime of x is greater than 0, we want to know for what values the function is increasing, and that means basically you have cos of x is less than 1/2 for some values that are less than 1/2, and that is where x is between, and if you double check, is between pi over 3 and 5 pi over 3. Then you just choose a value between pi over 3 and 5 pi over 3. Remember, if one is in the first quadrant, the other one was in the fourth quadrant. So it makes sense that anything in between will give a value of the function that is actually less than 1/2, right? Now let's look at the second part where f prime of x is less than 0. And if that is the case, that means cos of x is greater than 1/2. And if that's the case, then now you have two possible solutions. And one is all values from 0 to pi over 3, okay, not inclusive of pi over 3, or you have is greater than 5 pi over 3 and less than equal to 2 pi. Okay, so that's the interval in which the cos of x, which is greater than 1/2, and that is when the derivative is less than 0. Remember, we chose just the equation of the derivative, first derivative. We chose to solve this 1 minus 2 cos x and then less than 0, and then when you solve it, you get cos x is greater than 1/2. That's what you will get. Okay, so now that you have this, then we can go ahead and say, okay, so for what interval the function f of x increasing on what intervals? Well, interval pi over 3 to 5 pi over 3. So that's for sure, we know that. And then what it means is that the function decreasing on two intervals, and that is first from 0 to pi over 3 and 5 pi over 3. I have to make sure that the notation is correct. Is the round bracket and pi inclusive, okay? So, and that means now we can go ahead and say, okay, the local minimum, so f of pi over 3, you just plug the numbers in, is pi over 3 minus root 3. When you grab this pi over 3 and plug it back into the original function right here, you will end up getting pi over 3 minus root 3, and this is approximately negative 0.68 will give you local minimum, and f of 5 pi over 3, when you plug that number in, you get root 3 plus 5 pi over 3, and that is approximately positive, and that is 6.97 based on that calculation. And that is your local maximum, okay? And if we go ahead and sketch the graph quickly and a freestyle, you could see that pi over 3 is in between the two x-intercepts. So this is it. That's the graph, and finding out which area the function is increasing and decreasing based on the first derivative. In this case, we have a local minimum and local maximum within that interval. Okay, have a fantastic day and check out the next video, limits, differentiation, and using critical points.